So this unit 11, is the same as 9 and 10 combined, and we're going to be talking about doing 2 samples instead of just 1. So we're extracting data from 2 populations as opposed to just 1. So maybe we want to compare boys and girls, or we want to compare freshmen and sophomore. So we're looking at 2 different sets and then using confidence intervals and hypothesis testing to find the difference between the 2 populations. So here we have just some symbols. We'll now refer to it as P1 and P2 instead of just P. So now we're going to number them 1 and 2. You can also do a subscript, like if you're doing boys and girls, you could do P sub B and P sub G, like if you want to take the first letter. I usually just do 1 and 2. Then you have, now we're just denoting everything like with a subscript 1 or a subscript 2. Just the only difference. P hat 1, P hat 2. So here's an example, talking about duct tape. Some people seem to think that duct tape can fix anything, even remove warts. That's gross. So investigators at an Army Medical Center tested using duct tape to remove warts versus a more traditional freezing treatment. Suppose duct tape treatment will successfully remove 50% and traditional freezing treatment will remove 60%. Let's find the difference between the 2 samples. So like the last units, you start out with sampling distribution, which is like the first third of the unit, and then confidence intervals, and then hypothesis testing. So this unit is all 3 combined into 1. So here we have defined our variables, P sub freeze and P sub tape. Our sampling distribution for freezing, remember the mean is equal to P, and the standard deviation is what? So mu, so let's say mu of F equals P, and then standard deviation is the square root P1 minus P over N. And that's the same formula, but I'm just doing it twice now. Okay, so I did it for freezing and I did it for tape.
Wait, you just need P hat? 1 minus P hat? Or?
P1 minus P, because this is sampling distributions. If I were to combine to find the combined mean and the combined standard deviation, this will work. The mean, you just subtract the 2. So I would take 0.6 minus 0.5. And the standard deviation, you just add the 2 under the square root. Now, when I'm checking if something is normal or not, in the last unit, I did n times p and n times 1 minus p. Now we have to check 4 things. N1, P1, N1, 1 minus P1, N2, P2, N2, 1 minus P2. And all of these have to be greater than 10. So now you're checking 4 equations.
So it's just those 4 or is it everything else?
N1, P1. So that's how you're checking if it's normal.
Oh, okay. You still have write-ups?
Uh-huh.
So we just have to do a longer write-up?
Yes, a little bit longer. So now instead of just checking NP and N1 minus P, we're checking 4 equations to see if it's normal.
Greater than or equal to?
Greater than or equal to. So for the difference in the means, you subtract. For the difference in the standard deviations, you add. But you don't square them, you just add. And then to decide whether it's normal or not, you have to you have to check the 4 equations. Notice that it says, no longer do we say the sampling distribution is normal. We say the sampling distribution of p hat 1 minus p hat 2. So I want you to circle that in your notes. It's the sampling distribution of the differences in proportions. Conditions for confidence interval and for hypothesis testing are the same. We say that the samples are independent random samples. So I want you to underline independent random samples. If you don't write the word independent, I take off points. Independent random samples. Maybe. And it's samples, plural. The next one is you're checking the 4 equations. Now, why do these have hats and the sampling distribution one did not?
Because it's from the independent random samples.
Right, so when you're checking the 4 equations, confidence intervals have hats. Whoops. And this is true for like the rest of the year. Confidence intervals have hats. Remember I counted off points on that last test? Confidence intervals have hats. But then sampling distributions and hypothesis tests don't. So you use NP and 1 minus P for sampling distribution and hypothesis tests. The only time you use P hat in your conditions is when you're doing a confidence interval.
What do you mean by confidence interval?
Like when you're doing a write-up for a confidence interval.
So we can write up different things.
Mm-hmm.
Wait, so we might have to do 2 write-ups?
You might. The formula for confidence intervals is this right here.
Same thing, but
It's the same thing, but now you're finding, so it's the difference in P hat. We still call this our point estimate. The Z critical value is still the same way that we found it in the last unit. And then this is still my standard error. And then the whole thing after the plus and minus is called what? Margin of error. So that's why I try to stress that everything builds on each other this semester, because all this stuff doesn't go away. It keeps going. It just is in a different type of sample. So that's why I try to build a good foundation in the beginning so that we can just build off of that. So in your conclusion, if I were to interpret the confidence interval, then I would be like 95% confident that the value of the difference, you're going to now use the word difference in population proportions, is between like 0.2 and 0.7 or something like that. Interpreting the confidence level is still the same. It's how often you capture the true difference. So if I have a 95% interval or confidence level, then I would say about 95% of the time I'm capturing the true difference in proportions. So the main word for this unit is just difference. Steps for interval assumptions. Calculations. Conclusion. So same 3 steps. We're going to do a write-up together.
how do these conditions?
That's for a hypothesis test. But that was a good question, because you don't have conditions for a confidence interval.
No conditions.
I think the conditions are the same.
She answered you.
No hypotheses is what I meant. Is that what you were asking?
I'm just surprised you actually
No.
answered it.
I know.
I think it was the first.
It's a good question.
So
There's no hypotheses in a confidence interval.
That is true.
So conclusion, we are blank % confidence that the true difference, I'm going to highlight the word difference again because you need to say difference.
I did as best I could, but you might want to just.
So here's the question. It says, as part of a study, people in a sample of 258 cell phone users ages 20 to 39 were asked if they use their cell phones to stay connected while they are in bed. The same question was also asked of each person in a sample of 129 cell phone users ages 40 to 49. So already I have two groups, 20 to 39 and 40 to 49. And I have two different samples. How much greater is the proportion who use a cell phone to stay connected from 20 to 39 than for 40 to 49? It doesn't tell me what level I want to use. Let me see if I can tell. Does it say 95? 90. Okay. I'm going to go back because we're going to do this together. Do y'all have, is this all blank for you guys? Blank. Okay.
We have what's on your screen right now.
What does the next one say?
It just says assumptions with a colon.
Okay, perfect. So we're going to do a 90% confidence interval. So I'm going to start with my assumptions. First assumption is what? I need to say what word? Independent random sample. So I would say there are 2 independent random samples of adults. You could go into saying like ages 20 to 39 and 40 to 49, but you don't necessarily have to. The 2 words I'm looking for are independent random samples. The second assumption is checking the 4 equations. So I have N1 P hat 1, N1 1 minus P hat 1, N2 P hat 2, and N2 1 minus P hat 2.
Would we use just without the hats?
You use without the hat for hypothesis tests and sampling distributions. But you use the hat on confidence intervals.
So are we using the hat stuff?
We're using both. We're combining it. So let's do, so for N1 and P1, let's use the 20 to 39-year-olds. So it says for 20 to 39, I have 258 people and 168 out of 258. Uh, 258 minus 168 would be 90. So 90 over 258. Then the second sample is 61 out of 129. And what is 129 minus 61? I don't know. 68.
Yay, everything greater than 10.
So since they're all greater than 10, I would say the sampling distribution of, you could say P hat 1 minus P hat 2. You could say the differences in proportions. Either one. is approximately normal. Yes.
I thought you said sampling distributions don't have halves.
No, the sampling distribution of p hat 1 minus p hat 2. So that's just what it's called.
Oh,
You're finding the sampling distribution of the p hats.
I thought we were finding the
Do we not need to say it's less than 10%?
You do not need to say that it's less than 10%. You can. If you're just so used to that, then you can. In this case, it doesn't matter. You can say both samples are less than 10% of the population, but you don't have to. That's optional. I'm going to skip it because it's a lot to say. Okay, second part is the calculations. The name of this test, can anyone guess? Maybe if they
Two
can.
prop Z test.
2 prop Z. No?
Z interval.
Interval. So we're doing an interval. 2 prop Z interval. That is, let's see. The formula by itself, you're finding the point estimate, which is the differences. So p hat 1 minus p hat 2 plus or minus Z star square root. And then you're adding the two standard deviations together. So I'm going to add the standard deviations together. So p hat 1 minus p hat 1 over n1 plus p hat 2 1 minus p hat 2 over n2.
Is that on the formula sheet?
No. I mean, it's in words. It's in words.
I used the chart.
Okay, so now I'm going to actually calculate or type in what my numbers are. So if you go to Stat Test B, everyone with me? Stat Test B. Oh, you go to Stat Test B. I'm going to type in I want to see my PowerPoint. Where is it?
So I go with 3 fingers. Just for future reference.
Oh, thank you. Never knew that. Okay, so I'm going to type in what I know. So X1, N1, X2, N2, and C level. So X1 is 168, 258, 161, 129, and 0.90. So go ahead and type those in.
Does it matter if you do 0.9 or 9? Or 9?
I think you have to do 0.9.
I put 9 in and
It works. Okay.
Because I've never used 0.9.
I did it on accident.
Then you'll notice that it gives you the p hat 1 and the p hat 2. So I went ahead and did that first. So p hat 1 is 0.09 minus 0.47. Nope, that's not right. Sorry. I'm looking at the interval. 0.65 minus 0.47. Plus or minus.
Or can we just show you?
You still have to do the formula by itself, formula plugged in.
The Z-score is inverse norm still, right?
Mm-hmm. And Z star is going to be inverse norm of, if it's a 90% confidence level, it's inverse norm of what? Good. And you get 1.645. You might already have them memorized. And then your interval, I'm going to go out 4 decimal places, is 0.0911, 0.2655. So the last part is conclusion. So I'm going to say we are 90% confident that the true, what word am I looking for? Difference, the true difference in, what is my context? So the proportion of what? It says it in the problem.
Both on their phones and theirs.
Of cell phone users who sleep with their phone.
What does that mean?
Like, do you have it like charging beside your bed? Do you put it in another room? What are the two age groups? What are the two age groups?
20 to 39, 40 to 40.
20 to 39 and 40 to 49 year olds is between 0.0911 and 0.2, what is it, 0.2655? The next slide that I want you to go to is the one with the chart on it. It's just doing another example. So I'm going to skip the second example because I think that you guys are good.
Got it.
Okay. This right here. So in the last unit, I want you to circle this slide right here. Highlight it.
We skipped like 5 slides.
Yeah, it was just another write-up. I skipped it.
We should do it.
So, for fun, if you want to, you can. In the last unit, in our confidence interval, like how we connected confidence intervals and hypothesis tests, what number were we looking for? Not the p-value.
Alpha.
Nope, not alpha.
Alpha zero.
You just took a test on it. What number were you looking for? No.
Statistic.
No.
Population.
Z.
Population proportion. So, in the last unit, you were looking for the population proportion. So, on the test, I think it was 0.25 was contained, not contained. And that told me whether I rejected or failed to reject. So, if it was contained, then I failed to reject. And if it was not contained, then I rejected. In this unit, we are not looking for the population proportion. We're looking for the number 0. The number 0. If 0 is included, then we would fail to reject because there is no difference. Because the whole purpose is I'm trying to find the difference between the two populations, the two proportions. If you have an interval that is all positive numbers, then that means my P1 is greater than P2. And if you have all negative numbers, then that means that P1 is less than P2. And so in the example that we just did, we got 0.09 to 0.27. So which case does that fit into? The first one. Both of these you would also reject. So I'm going to put reject HO next to it. And you would fail to reject HO for if 0 is in it. Bless you. So, if they're all positive or all negative, if 0 is not included, then you would reject. So, in this case, I have all positive numbers. So, then I would reject the hypothesis that there's no difference between 20 to 29-year-olds and 40 to 49-year-olds. So, I was actually able to prove, based on my confidence interval, that more 20 to 39-year-olds sleep with their cell phones next to them than 40 to 49. Does that make sense? Kind of? Because I'm trying to find the differences between the two. So I'm taking 20 to 39-year-olds that that sleep with their cell phone minus 40 to 49. And if I get a positive answer, that means more 20 to 39-year-olds sleep with their cell phone than 40 to 49. The whole interval is positive, so that means that P1 is greater than P2. So just think for this unit, I'm looking for 0 in my interval. Not the p-value, not the population proportion. I am looking for the number 0. Last part of this unit, and then we'll be done. Yeah.
There's like 3 more pages.
Yeah, there's like, well, it's just a lot of examples. So we're just going to take this unit and we're going to get a lot of practice with it. Okay, so the same assumptions for a hypothesis test. It just rewrites them for you. The hypotheses, you'll now say that the null hypothesis is that P1 equals P2, P1 is greater, P1 is less, or P1 is equal to P2. So now you will no longer have numbers in your hypotheses.
No.
This is crazy. No numbers.
No.
Then
What?
you will want to define, that's a highlighter, you'll want to define P1 and define P2 in context.
Do not put it.
Do not put it.
Ready?
Where's the
So these would be the hypotheses right here. This is the formula for the test statistic. So the numerator is p hat 1 minus p hat 2 over. This is the only thing that I will say that you must memorize going into a test or the AP exam, like a formula.
Why is there a C by it?
This is not on your formula chart. I have not seen this kind of write-up very often on a free response. We still teach it because it's shown up like once or twice. But what the p hat C is,
Oh.
it's the combined proportion. So this would be the formula that you do need to memorize.
I don't know which.
It's just taking your total successes in the samples over the total sample size. So it's just combining your proportions.
I don't know whether to use this.
It's basically like finding the weighted proportion.
I don't know whether to use this right up or this.
It'll either ask you for a confidence interval or it'll ask you to do a hypothesis test.
So it's every success over everything.
Mm-hmm.
This is hypothesis.
And that goes here, 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 and here. But you'll notice that your denominators are still different in 1 and 2. So this is my test statistic. Once you get that, the way to find the p-value is still normal CDF, still the same rules that apply. Hypotheses, assumptions, same assumptions, calculations, conclusion. Same conclusion, since the p-value is less than or greater than alpha, I reject, fail to reject. There is or is not sufficient evidence to suggest the alternative. Same thing. Okay, let's do a write-up example. A survey was conducted by Gallup to investigate the public opinion, blah, blah, blah. Americans were asked whether he or she would consider buying an electric car if gas prices continue to rise. In a low-income sample, 65% said that they would not buy an electric car. In a high-income sample, 59% responded that they would not buy an electric car. Suppose both sample sizes were 300. This right here, Freddie, to answer your question about whether you know to do a confidence interval or a hypothesis test, it says, is there convincing evidence? Also, it's going to give you an alpha, and a confidence interval would say create a confidence interval. So you're going to know.
So it'll all the same.
So this means that I'm doing a hypothesis test. If it doesn't say that, it's going to say create an interval.
And would you say for the other one, confidence interval, it will ask?
Confidence interval will say create a 90% confidence interval. Like it'll tell you. Yeah. Okay, what I want you to do, actually, I want you to try and do this one on your own.
Oh my.
And then we'll check our answers. So try doing this one on your own. Okay, here are the hypotheses. I like writing it where you have P1 on one side and P2 on the other, like P1 equals, P1 is not equal to. I think in the PowerPoint it says like P1 minus P2 equals 0. I don't really like that. I like putting it on either side. Make sure that you define P1 and P2 as true proportion of low income and true proportion of high income.
So the ho's always the same.
Yes, the null hypothesis is always the same.
You wrote a week on it.
Okay, next up, I want you to do the assumptions. Something that I do want to note, though, is when you're reading the scenario, reading the prompt, does it give you any population data?
No. Does it?
Does it just give me samples?
Yes, sample size.
Does it just give me samples?
Yes.
Yes, so I'm going to have to use NP hat 1 and NP hat 2 whenever it comes time for the assumptions.
But wait.
So my assumptions are the same for confidence interval and hypothesis test.
It's supposed to be P though.
But I'm not given P. So my rule of thumb for how do I know when to use P or P hat? Does everyone look at me really quickly? How do I know when to use P or P hat? If you're not given P, if you don't have it at all, then you don't use it. You default to P hat. But if you are given P, like the population data, then you use that. So always. But you won't be given to it. You won't be given it to you in a confidence interval. So next up, I want you to try the assumptions. Okay, for assumptions, you have 2 independent random samples. Then you're checking the 4 equations. And you should say the sampling distribution of P hat 1 minus P hat 2 is approximately normal. That is for assumptions. Okay, on calculations, I'm just going to write it out. You're going to put the name of the test. In this case, it is a 2 prop Z test.
Oh, test, not interval, because it's...
Then you're going to do the formula by itself.
Is there a calculator trick for this one?
Yes.
How many of those different answers do we need? Oh, so it's...
And then
This is one.
formula plugged in.
Okay. For me, I have to write it out.
Then on the side, you know how I had you highlight the things that I would definitely be checking. The things that you definitely need to list out are your Z, which is your test statistic. You need your p-value. You need to show how you solved for p hat C,
How do you run P hat C?
the formula.
Yeah, you were paying.
And then you need your alpha.
That's always everything.
So these 4 things. In your calculator, the name, like how to get to the test, is going to give you all of these. It is stat test 6. So stat test 6.
200 or 300?
So when you go to stat test 6, it's going to have you type in X1, N1, all of that. What I did is just 0.65 times 300, and that gets you 195.
And that's already done from your
Oh my
assumptions.
god.
Uh-huh.
Your thing was about to fall out. I'm trying to do a good thing, and you're yelling at my
X2 would be 0.35 out of 300, which you get 105. N2 would be 300. Then I would choose the P1 does not equal P2 option
I got 0.13 for P.
and calculate.
Anyone else?
Wait, but it says
I got
0.5, but it says
2.02.
59% responded this way in the problem. So why'd you?
Oh. I don't know. I should have done 59. I think I was doing 1 minus. I'm sorry. So what do you get when you do 59% of 300?
177.
2.02 to the negative 13.
Are you identifying?
So
Maybe definitely wrong.
177 out of 300.
Mhm.
Sorry.
You're fine.
Okay, so then I'm going to show you what each number means in the calculator. So Z is your test statistic. You should get 1.514.
I was gonna say it myself.
The next one is your, so below that it just says P, that is your P value. So 0.13. You could say 0 if you wanted. P hat 1 is 0.65, P hat 2 is 0.59. Then the P hat by itself is P hat C.
2.62 is
Yeah.
PC.
It doesn't give me alpha, so let's just say it's 0.05.
So you don't need P hat 1, P hat 2.
But it's just
No, well, you'll need it when you're plugging it into the P hat C formula.
Come on.
Okay, so this is what I want for on your calculations. You're gonna put 2 prop Z test. You're gonna show your work for how you got P hat C. You're gonna show your work of how you got Z, like the test statistic. So these are the two formulas.
Oh, only 2 formulas.
Oh, so you don't need the main one.
So we don't need to.
This is the main one right here, test statistic.
We don't even have this slide.
Oh, I thought the main one was P hat 1 minus P hat 2.
This is P hat 1 minus P hat 2 over P hat C 1 minus P hat C.
But we don't need
and
the
one.
one where it's plus or minus Z.
No, that's confidence interval.
Oh, okay.
So things you want: P hat C, test statistic, P value, alpha.
So these are the 4 numbers, and then you want those 2 points. There's 3 formulas.
Okay, when you finish thinking, or when you finish writing your own, check your answer. So since P value is greater, I fail to reject.
So leave it up for like 10 minutes.
Then there is not sufficient evidence to suggest this whole thing right here. I know it's a lot, but it comes straight from the problem. So you are just copy and pasting it from the problem.
Except we can't copy and paste it. That's what they.
You have to write it all. Yes, you do.
Can this test be online?
No.
Can't copy and paste in lockdown, so how's that?
Avoid making these common mistakes. So
I'll make those.
don't make them, Drew. Don't make them.
I always make stupid mistakes.
We can break even.
I make stupid mistakes.
So
I will not make this copy.
remember that the results from your hypothesis test never support the null hypothesis. So that kind of goes back to me saying the null hypothesis is never true.
It's written.
So in 2 sample situations, you shouldn't be convinced that there is no difference. It just means that you can't prove that there is no difference. Yeah, you fail to reject that there is no difference. So this is saying that when you see that the null hypothesis is true, that's never correct. So in the context of this chapter, it's going to say there is no difference,
So there is no.
which is the same thing as saying the null hypothesis is true. So if you see the words, there is absolutely no difference between the two,
It's wrong.
that's wrong. You're trying to prove that there is a difference, and if you can't prove it, then
So we always reject it.
no. You reject or you fail to reject.
Fail to reject it.
Second thing, if you have a census, then there's no need to carry out a hypothesis test.
It would be inappropriate to do so.
It would be inappropriate to do so. So if you have the population data, you don't need a hypothesis test.
If they have p-values or hypotheses.
If you have the population data, you don't need to do you wouldn't need to do a hypothesis test or a confidence
So
interval.
we're always going to be given a sample.
Mm-hmm.
Don't be inappropriate. Don't carry out.
This one is, I'm gonna skip this one. So whenever you are, like the connection between confidence interval and hypothesis test, what this is saying is, like, I guess practical significance versus what your numbers say, just so interpreting the data. Like in that example where we were talking about cell phone users, the practical significance, I think we got 0.09 to 0.27. What that's saying, like if I were interpreting that practically, I would say that 20 to 39-year-olds have, or use their cell phone anywhere between 9% to 27% more than 40 to 49. So that's just another way to interpret confidence interval. That's what these numbers represent. So just looking at the confidence interval and taking it a step further. So not only did I find that there was a difference, but with the confidence interval I was able to prove it was a 9 to 27% difference. Correctly interpreting confidence intervals for two sample is more difficult than one sample because you're doing the difference between the two. So do not forget that we are looking to see if the interval includes 0 or not. If 0 is included, then what decision do I make? I fail to reject, which means that there is no difference. I fail to reject a difference. If 0 is not included, then I reject. And I have proven that there's a difference. If I get a positive, then it's a greater than. If I get a negative, then it's less than. That is the last one.